Hi folks, Joseph Kursky here with you discussing linkages between GIS, Earth Day, and environmental education and management. Right now we're on reason number 3 that these things are connected. So the third reason is as follows. One of environmental studies' central themes is examining the interaction between humans and the environment. How does the environment, through such characteristics as daily weather and long-term climate, native plants and animals, landforms, the availability of water, local and regional natural hazards, and the type of predominant soils affect people? How do these factors affect the growth of cities, sustainable agriculture, water quality and quantity, tourism, culture, and population growth and change? Conversely, how do humans affect their environment? Humans represent the largest change agent on our planet today, affecting their local and regional environments, and in the past 200 years, their impacts have been increasingly noticeable on a global scale. These impacts include the clearing of forests and other natural vegetation for agriculture, urbanization, water-related projects from the building of dams to the widening and deepening of river channels to groundwater withdrawals, burning of fossil fuels, building seawalls, mining, construction, and in thousands of other ways. Environmental issues are bound up in scale, in place, in cultural practices, in the biosphere, atmosphere, lithosphere, hydrosphere, and anthrosphere, the human sphere. Thus, to use GIS effectively to examine human-environment interaction requires a firm foundation in environmental content, skills, and the geographic perspective. Now, fourth, studying environmental issues with GIS lends relevancy and real-world context to these issues. The central themes that environmental scientists and geographers have studied for years have in recent decades become topics on daily newscasts. Pollution, traffic, habitat loss, climate change, erosion, and many others have caused some to claim that the 21st century is indeed the environmental century. In recent years, 3 aspects of environmental concerns have become evident. First, environmental concerns have become global issues. Second, environmental issues increasingly impact the everyday lives of everyone on the planet. Third, environmental issues are complex and require a different kind of thinking, a thinking that not only crosses borders of countries or ecoregions, but also that crosses traditional disciplinary boundaries. Geography and environmental studies provide the means by which students can develop that kind of thinking that will help them make sense of these issues on multiple levels. For students to understand ways to live in harmony with the environment, they need to understand the connections with their own actions and that of their fellow human beings to global processes. And therefore, they need to understand the principles of those processes. These processes include such diverse topics as the carbon cycle, global trade, Earth-Sun relationships, and climate. Because environmental studies have become more quantitative, experimental, and analytical during the past century, GIS is the perfect tool, in my view, in which to study environmental processes through databases, maps, workflows, models, and spatial statistics. Fifth, teaching about sustainable practices in agriculture, urban development, ecotourism, energy, or any other field using GIS requires a grounding in core concepts in ecology and geography. It is not enough to know only content because environmental phenomena interact, right? They move, they change. Therefore, relationships and processes are critical to understanding. GIS can foster each of the Center for Ecoliteracy's, go to ecoliteracy.org, 6 core ecological concepts: networks, nested systems, cycles, flows, development, and dynamic balance. So that's networks, nested systems, cycles, flows, development, and dynamic balance. GIS allows variables to be input, modeled, and modified so that the dynamics of environmental processes can be studied. Hungerford and Volk in 1991 outlined 9 key ecological concepts that they said were necessary for environmental education programs, including individuals and populations, interactions and interdependence, environmental influences and limiting factors, energy flow and nutrient cycling, community and ecosystem concepts, homeostasis, succession, humans as members of ecosystems, and ecological implications of human activities in communities. GIS can enhance the teaching of all of these concepts. A current NSF-funded project on environmental literacy from the NAAEE has resulted in a definition that includes 4 interrelated components: competencies, knowledge, dispositions, and environmentally responsible behavior. By using the same tools used by scientists, GIS aids the first 2 of these, and by investigating real issues in their communities and beyond, GIS aids in helping with the last 2 of these components. Thanks.